All right. That was the band. Those of you who know the Last Waltz, doing a Marvin Gaye composition. Maybe just don't do it. Hope I got that right. I always get that wrong. I thought I'd start the show that way today, in keeping with the Marvin Gaye spirit. Little mix it up a little bit. My guest today is Dr. Frank Wang from the Math, Engineering, and Computer Science Department, Division of Academic Affairs. Say hi, Frank.
Hi, good afternoon, Hugo. Thank you for having me.
Thanks for being on. And by the way, I always forget to introduce myself, Hugo Fernandez. The show is What's Going On. I'll be your host here on LaGuardia Web Radio WLGR. Frank's on to talk a little bit about a paper he's written, and he's gotten a lot of attention for using COVID-19 vaccine efficacy data to teach one sample hypothesis testing. That's a dead sexy title, Frank.
Well, my original title was not this complicated. Actually, my editor decided to make it more searchable or something. So,
like put all the words that matter in there, like COVID-19 and vaccine.
That's right. So I hope we will be able to talk about the vaccine. It's not that complicated.
Yeah, no, and well, hopefully, the idea here would be that, having you on is going to hopefully simplify, but we're going to get to that. Sure. But as I told you, why don't you talk a little bit about yourself, Frank? Tell us a little bit about your background, your studies, where you come from, things like that.
Sure. So I came to LaGuardia Community College in 2004, so it has been a while. But by the way, if you hear the siren outside, we live in New York City. Just for that.
And actually, I live in Connecticut.
It's snowing pretty heavily. I'm sorry to be distracted. Let me start again. I came to LaGuardia in 2004. Before I came to LaGuardia, I went to Columbia University. That's where I got my doctoral degree. My degree was in mathematical physics. So in LaGuardia, I have been teaching. In the beginning, I have been teaching primarily engineering students. That's the beginning of our engineering program. For those people who are in this discipline, you might realize that before you actually take serious engineering courses, you need to go through a lot of mathematics course like calculus, differential equation, along with general physics. So that has been my primary concern. I was also involved in the program to help students to develop their basic skills. We know that there are some students, they unfortunately did not have the resource to learn mathematics properly in their high school, so they need to be they need to some development for them to get ready for college courses. So I have been dealing with college algebra to help some of the students. So I think I have talked about a lot.
You gotta, it's interesting because I go through the format. Usually we talk about the LaGuardia experience,
right.
But you touched on a lot of points. Could you explain, when you say mathematical physics, what is that? Well, I don't know why I had assumed that you had studied, you were an astrophysicist for some reason.
Okay.
Was I wrong there?
Oh, sure. Yeah, that's my childhood dream. I believe I was 10 years old. I heard a story that there were only 3 people who could understand Einstein's general theory of relativity. So I was aspired to study Einstein's theory of relativity, which is very mathematical. In my PhD thesis, my focus was to find some observable evidence to support Einstein's theory. So that involved compact objects like neutron stars and the black hole. So yeah, you can consider that I have try to use astrophysical evidence to support Einstein's theory of relativity. That's the mathematics and the astrophysics part.
All right. Do you understand it? Did you achieve your goal in life?
I think I understand now. And I think the legend was not true to begin with. There are far more than 3 people who understood his theory. I think, as a matter of fact, if you study hard, you can understand that that's how I inspire LaGuardia students to understand, provided you are interested in black hole.
Right. Well, I mean, I read Stephen Hawking's Brief History of Time, and I'll admit I got lost somewhere around string theory. But
Okay.
up until that point, I thought I was following along because he does explain it so that a layman, whatever you want to call it, a non-mathematician could understand. I didn't get past geometry, Frank, in the
Right.
11th grade, and I got to admit that was my fault. I probably did. I wasn't showing up to school prepared to learn. I'll admit it. So that explains why I'm so illogical. If you ever had an argument with me.
No, I think not showing up and wearing my professor's hat, that's probably never a good idea.
Yeah, exactly. I think that year I missed more classes than I went to. And it's too bad because, to be honest, I enjoyed math up until that point. But so you get the degree at Columbia. And what were your notions? I mean, did you have aspirations after that?
So, so after I graduated from Columbia, I realized that I really want to stay in New York. I really want to be in the city. So that really limited my option. I actually briefly contemplate having a career in the financial industry. At the time, there were some people with strong quantitative trainings. They eventually applied their quantitative skills to investment bank. I actually explored that path, but eventually I still end up in education, which I enjoy, and I think that's much healthier for me.
All right. So when you came to LaGuardia, was that you just answered the ad, or was there anybody that suggested investigating CUNY or investigating LaGuardia specifically?
I think I was just answering the ad. I was reading the New York Times. I remember back then, that's the Sunday New York Times. There's a section in educational jobs. So
Right.
I believe that's how I got involved. And so I have to say that my world view before I came to LaGuardia was quite limited. I didn't really know too much about higher education beyond the research universities. So it was, I am really appreciating the experience I have at LaGuardia after 16 years.
I mean, you didn't mention this, but you it was. I'm guessing English wasn't your first language, right? And
No.
Were you raised in the United States, or?
I grew up in Taiwan. I received my undergrad education in Taiwan. Then I came to New York in 1993. So that has been, since then, I have been in New York.
All right. That's about the time I've been here, too. We have a lot of parallels. And you mentioned the fact that the two of us met, interestingly enough, in something Rosemary Talmadge, the late Rosemary Talmadge, put together, which was Difficult Dialogues, the workshop with the Center for Teaching and Learning, and which was about talking about religion in the classroom.
Yes, I remember.
How did you end up in that? I mean, here you are as a mathematician. What made you want to aspire? I mean, that particular workshop of all workshops to kind of go into, I think, right when you first got here, right?
Yes. So for those people who are unfamiliar with the project we are discussing, Difficult Dialogues, I believe that it was supported by the Ford Foundation.
Yeah.
That was around 2006, 2007, if I remember right, just a few years after the September 11 events. We are trying to see how do we facilitate dialogues for a very diverse student population. And this came back to what I described earlier, that I have been engaged in teaching engineering students, but also a lot of students, they come from different backgrounds. And for me, my motivation was to see if there's a conflict between science and the religion. Just like for me, I teach physics. I don't really teach cosmology, but some people might have questions about the cosmological impact, and I should say the discovery in science might have impact to their religious view. And also, I think that's probably particularly more relevant to those faculty members who teach biology. When we talk about Darwin's theory of evolution, sometimes it can be a very emotional issues for students. So that was the time, my motivation to join that seminar series, hopefully to learn more about LaGuardia, about LaGuardia students, and about myself and about my colleagues.
Yeah, no, it was a fabulous workshop. And I remember afterwards, though, you moved into Quantum Leap, right?
Yes.
Quantum Leap was the next series of CTL that you got involved. You want to talk a little bit about that program?
Sure. So that come back to the conversation we had earlier. In LaGuardia, we have quite a lot of students at the time. I believe at least 2/3 of the students, they need developmental educations. And at the time, students, they need to go through a lot of the material they have missed in high school to just try to catch up in one semester. So the failure rate was very high. At the time, the current provost was holding the position of Dean for Academic Affairs. So he conceived the idea to teach elementary algebra through complex and important current issues such as public health and global climate change to interest students to learn mathematics. So working with Dr. Acario, we developed a grant which was funded by the U.S. Department of Education that initiated the project Quantum Leap to help students to better contextualize mathematics.
You want to talk about a couple of things you developed during that program that could illustrate how it worked?
So I was just talking to Paul the other day. At the time, we had external consultant Dave Ferguson. He's a professor at Stony Brook University. I remember he presented one problem that's eventually I changed that to mammography problem. So the problem is that if you have breast cancer, the probability you're going to have a positive mammogram is 80%. However, the inverse probability is not the same thing. It's not the same thing that if you have a positive mammogram, then your probability of having breast cancer is 80%. That's entirely wrong. Actually, even if you have a positive mammogram, the probability will be much lower than that. So this was the problem that Dave Ferguson introduced to me. And that was, in a way, I was telling Paul that's almost like a turning point to guide me to think about a lot of the issues that will be relevant to students. The other topic I remember for teaching Math 096, that's what we call elementary algebra. Another topic was the AIDS epidemic. So that was another topic because it was 2006 or 2007. Some people thought the crisis is over, but it's far from that. And you have to have a quantitative understanding to see the data, to understand the magnitude of the problem.
What is the magnitude of the problem?
So for me, I think the the most important or one of the very influential moment that got my attention was that I was reading a paper that was written by a group in the World Health Organization. So they are analyzing data in South Africa. I think all of us have heard story, and we know that AIDS epidemic, it's such a horrible situation. But what struck me the most was that when I was trying to solve the equation, I realized that the eventually in South Africa, at least at the time, if the infection rate does not change, then for every newborn, essentially they are just born to be killed by the AIDS epidemic. So basically, the population size will not change, but just every newborn, eventually, there's a high probability you are going to be impacted. So that was the moment that I realized how serious the situation is.
It's funny because I obviously AIDS has taken a back seat to the coronavirus or COVID-19.
Yes.
And I have a friend who comes on regularly. He's a satirist from Berlin who has a website, whatever, a blog, and one of the things he likes to tout is the survival rate of COVID, which I
Right.
think is 99.7. And so that means that basically of the folks who are exposed to it, your
Right.
chances of dying are 0.3%. But
Right.
I multiply that times what I assumed was the world population, which
Hmm.
is 8 billion. My
Right.
assumption that
Mhm.
comes out to 24 million people.
I mean,
And
exactly. Yeah. Right, right.
and but that's death. Obviously, that's if everybody was exposed.
Hmm.
I mean, I think that and what I disagree with him is the toll it's taking on the medical profession, and
Hmm.
the cases of people who end up in urgent care in the hospitals, and they see obviously the worst cases.
Right, right.
But
Hmm.
when you do math like that,
Hmm.
you know 24 million is basically, I was trying to find a parallel number, and that's basically the number of deaths in the Soviet Union during World War II, of all the different, everything from military, uh,
Right.
they were in the military, or civilians, whether it was by famine, disease. So
Right.
to make the numbers real, when you were studying in school, you were studying to be a research mathematician, right?
Yes.
And
Hmm.
but here in LaGuardia, do you think that a lot of your scholarship has led to more the scholarship of teaching and learning?
Yes, I have to say that since I come to LaGuardia, I probably not uh, have not written too many original research. So a lot of the papers I have written that's about reinterpreting the existing result or try to find a way that's easier for our students to understand. And in just to echo what you have said earlier, to develop students' quantitative reasoning skills, that has been a focus since I joined Dr. Acario's project. And I really think that people need to really look into the number to understand the magnitude. Otherwise, we are exposed to percents. And this is the kind of wearing my professor's hat. I have always tell students, when you look into percent, you have to ask yourself a question: percent of what? So just like what you have done earlier, 99% of the population of the earth, or 1% or less than 1% of the population, they can translate into millions of people, and uh, that's a significant amount of people, to say the least.
So, would you say in the work that you've been doing with with in teaching and learning, what we call student-centered scholarship, right here at LaGuardia, where we think
Yes.
of the community college as student-centered, that are we winning this? Are we winning this battle? Are we, are we having an impact on our students who come to us? Who, I think it's when we used to do the testing. I think we found that mostly that almost, I forget what the number was, 80% needed some sort of intervention in
Right.
mathematics.
Yes.
And are we having an impact on with the work we've been doing?
So I have to say that it will probably not be practical to see that we do something and students are doing well. So if we look into different domains, and that's the famous Bloom's taxonomy. They are the psychomo what's the I forgot that the second, that's cognitive domain, and the attitudinal domain. So at least I will say that for my own experience, students after they took my course, they realized that they need to have a quantitative mind to negotiate with this complex world. So but back to the question about how many people they actually develop their skills, I would say it makes some difference, but I am hoping that I can make more difference to empower students to actually uh, critically think about numbers.
Right. I mean, I always say that I'm not a lot of times. I mean, I'm teaching content, but
Mhm.
I'm hopefully what I'm teaching students is how to keep learning, because this is
Yeah,
we get them at the beginning. And if
right,
we
sure,
can kind of give them the skills that are going to make them better students,
right,
I feel, some sort of success. I have to focus on around writing, because I teach a lot of writing intensives. So
right.
I don't do it so much in the numerical order, whatever, inquiry and problem solving. I mean, there is some research, but
Mhm.
I'm not teaching the scientific method,
I mean,
which is,
you can. It's not too late to start.
well, you know what there's a part of me that wants to go back and take geometry and
Right.
see if I could get it. And I remember taking one of the last courses I ever took in college was a prep course for a test I had to take. And that professor, he was fabulous because he could really break things down
Right.
and help you understand it. It wasn't just, a math problem.
Mhm.
And he excited me about math. For a little bit there, I
Right.
said, wow, maybe I
Right.
should major in math.
Well, I didn't know that.
Yeah, but whatever. I call, and when our departments used to be next to each other. Remember, before
Right.
humanities moved? So I used to call mathematics the most abstract of all the art forms, because you're talking in abstractions, right? I mean,
Right.
usually when you're talking to people, the numbers are abstractions of
Mhm.
ideas. They're not sitting down and counting what we call like manipulatives. And
Right.
when I ran after school programs, I had a second grade principal ask me if I had manipulatives, and I didn't know what she was talking about when she told me, little things that they can count to do the math problems. And I said no, and she says, then you're not doing math.
Right.
But with these large numbers that you guys work with, how do you, when you're multiple decibels or whatever it is, or multiple with commas, it is an abstraction that kids have to wrap their head around, right?
Yeah, so this is also I mentioned several times already that I use the phrase quantitative reasoning. In a way, this is the concept that's relatively new that was in the probably late 1990s, early 2000. There's a recognition that students they learn mathematics, but they in math classroom they primarily learn mathematical operation. How do you handle, how do you multiply decimals, how do you convert percent to fraction, this kind of problem. But quantitative reasoning is really, my definition is contextualized use of numbers that requires thinking skills. So it's not just manipulation. You want to be able to understand. Back to the question I ask my students to keep thinking. When you talk about percent, you want to understand percent of what. So and that has a lot of the social content. So it's really not just a discipline in our department. It should be an interdisciplinary approach to guide our students to understand the quantitative concepts.
So you're saying we should have mathematics in the disciplines the way we have writing in the disciplines, or
yes. It's a matter of fact. Yeah. So that's one of the initiative after the project Quantum Leap. I and my colleagues at Lehman College, we applied for a grant from the National Science Foundation, and we have a program, a very catchy name called Niche. That means numeracy infusion course for higher education. We try to use that. It's similar to LaGuardia Center for Teaching and Learning, but we gather faculty across CUNY colleges and in different disciplines. So I think we have English literature, we have political science, we have I have two collaborators. Esther Wilder, she's a sociologist, and Dean Hurley, she's an economist. And we have basically every discipline you can think of. We have discipline from art. Yeah, we definitely have people from the art.
There's a lot of math and photography. But it's 1:29. I want to take a quick, or it's actually 1:30, take a quick station break. So you're watching What's Going On. I'm your host, Hugo Fernandez, here on LaGuardia Web Radio, WLGR. My guest today is Dr. Frank Wang from the Math, Engineering, and Computer Science Department of Academic Affairs. And we are going to start talking about a paper of his that was recently published, and it's gotten a lot of notice, certainly here at the college, using COVID-19 vaccine efficacy data to teach one sample hypothesis testing. And so, it's about 2/3 of that title I've got, Frank. So probably could you start by explaining what one sample hypothesis testing is?
Okay, so well, maybe Hugo, if you don't mind, I can.
Well, it's your paper. You explain it the way you wish.
So the origin of the paper was on November 18th last year. Pfizer gave a press release announcing their phase 3 clinical trial results. So basically, the way they do clinical trial was that Pfizer recruit about 40,000 volunteers, and they separate the volunteers, half of them in placebo group, so they give them a fake shot, and half of them they give a real vaccine, and they wait until about 170 people who got COVID positive. So by examining those 170 people, 162 are in the placebo group, only 8 are in the vaccine group. So back to what Hugo asked me about the one sample hypothesis testing, just from what you have heard earlier, you have 2 groups of people. So the correct procedure should be a 2 sample hypothesis testing. You have the control group and you have the vaccine group. But to learn this kind of statistical technique, you need to have that's a more advanced course. That's at least MAT 121. You are not going to learn that in MAT 120. So what I was trying to do is to find a simplified treatment so that I can just use I can use one group. That group means those 170 people who have COVID positive test, then use that to determine whether the vaccine is effective or not.
Yeah, well, yeah. You might have to unpack that a little bit more. But
Sure.
so how do you, the notion is in the creation of this lesson plan and the teaching is that the students are more invested because we are living through this pandemic.
Right.
And so the numbers are going to produce some sort of understanding for them about something that's serious and frightening. Is that the thinking?
Yes, and probably I need to I need to explain hypothesis testing since that's right in.
You have to, and I'm the perfect model because I don't understand anything.
Sure,
So if
sure,
you
yeah, and
if you
this is
explain it to me, the audience is going to get it.
sure. Well, I mean, it's not. This is just a concept we have to get used to. In back to what Hugo we were discussing earlier, at least when I study mathematics, we have equations, and then I eventually study physics. F equals ma. When you give a force, you can program your rocket to bring a spacecraft to Mars. That's very deterministic. But when we deal with a complex system like biology, we don't really, we almost never have a concrete conclusion. So we have to apply statistical methods. The story of hypothesis testing is the following. The beginning was there was a woman, a British woman. They have to, in the afternoon, they have tea time. So one woman, she made a claim that she can differentiate the taste of the tea if you pour tea into milk or you do the other way around. So this is a very complex problem because you have so many molecules, you have tea, you have milk, and so on. So how can we know that her claim is realistic? So the statistician who developed the concept, that's Ronald Fisher, he said that let's test her. So that's the concept hypothesis testing. Ronald Fisher, he prepared 8 cups of tea, and 4 cups they put milk into tea, and the other 4 cups they do the other way around. Then they ask the lady to drink those 8 cups of tea and identify which one is which, and then she correctly identify all the 8 cups. So the probability of accomplish that is 1 in 70. So this is the idea that you can argue that she was just lucky to be able to identify the just by randomly guess what's going on. But 1 in 70, that's a very small probability. So that a more plausible explanation is that she does have the ability to discern whether the milk is added to the tea or the other way around. So when you make a claim that's a hypothesis, we use statistical method to see what is the probability your claim is correct. That's the essence of hypothesis testing.
All right, and somewhere in there, when you were saying that, I started thinking of, because I've seen Contact,
Right.
Jodie Foster movie,
Uh, right.
Occam's Razor, and so what's the simpler answer, that
Right.
1 in 70, or the fact that she does have this ability to
Right.
actually differentiate?
That's
Is
right.
is the 1 in 70 as a result of whatever number of different kinds of teas they were serving times the number of cups or something like that? Is that how you
Yeah,
figured
so
out that
that's
number?
yeah, so that's basically you have so basically you have when you have your first pick, you have 4 out of 8 for the probability to get that right.
I see.
The second cup, you have 3 out of 7. So when you multiply all the probabilities together, that's
So
170. Yeah.
I see, and as because after you've eliminated a
Right.
flavor,
Right.
then
Right.
did they tell her when she was right as they went?
Uh,
That's too
I,
detail oriented.
that's right.
Uh,
But
as
by
I
the way, Hugo, maybe this is a little bit, I don't know if this is a little bit off the topic. A few years ago, in the World Cup, the soccer game, I know like we have a lot of LaGuardia students who are into the soccer. I remember they have an octopus, and that the octopus can predict the correct team. Do you recall the incident?
I'm not a soccer fan.
Okay.
It was funny because years ago when we were talking about teaching statistics,
Mhm.
I was speaking. It was Glenn. I forgot Glenn's last name. Who also teaches in the math?
Henshaw, yeah, Glenn
Yeah,
Henshaw, yeah.
I was saying, well, so many people play fantasy sports,
Hmm.
and fantasy sports is completely based on statistics. And
Right.
wondering if there was a way to, like you start out the semester, everybody gets a team, they build
Mhm.
their team, and just through statistics, figure
Right.
out who wins the World Series in that sense. But
Right.
at the time, he told me, well, more people are interested in soccer than they
Hmm.
are in baseball,
I
which I
think
find,
so. Yeah,
because of the internationalness of our population.
that's right.
I was reading in that the interview that I saw on LinkedIn about the paper that a lot of students had aha moments as a result of this of the lesson. And you want to talk about that, how students responded to your
Yes.
yeah.
So, so back to the hypothesis testing and back to the Pfizer's example, we have seen that they have to wait until 170 people to get COVID to be statistically significant. So if you have if the vaccine is not effective, which is always the no hypothesis, we always, just like when you go into the trial, you assume someone is innocent. So you always assume the vaccine doesn't work. So if that's the case, you anticipate 85 cases in the placebo group and the 85 cases in the vaccine group. But when you see 172, I mean, sorry, among 170 cases, 162 are in the placebo group. That's like you toss a coin 170 times, you get 162 hits. That's, you can use a simple probability to calculate, and let me tell you, the number is 10 to the minus 38. You have to wait until the entire age of the universe and much more than that to see this happening by chance. So from this understanding, we reject the null hypothesis and conclude that the vaccine is making a difference.
Right.
And so this is really it. This is the idea of hypothesis testing. But since you mentioned that I have students have the aha moment, but I have to say that not every student have the aha moment. So I was a little bit, if I say a little bit disappointed, but also I understand that human being, we have emotional need to have certainty. If you give a probabilistic answer, sometimes it's just hard for students to accept. But I believe it's important to inform students, to make them understand how they can make a judgment if they don't have complete information.
Well, here's an interesting, and I can't remember where I got this from, but supposedly, let's say you have to make a quick decision,
Mhm.
right?
Right,
As opposed to a reasoned decision based on facts.
right,
uh, Chances are that whatever the quick decision is you make,
right.
the chances are better that that's the right decision as opposed to the reasoned one. And I can't remember where I found this, but I talk to my students about this all the time because they think that, for example, making a photograph is something you can predetermine, figure out, and guarantee success.
Right.
And I try to dissuade them from that, and I try to get them to respond from
Mhm.
the gut,
Right.
and tell them that if you trust your own instincts, you're going to make good pictures. And anyhow, I don't know
Yeah,
what
so
you're saying.
Yeah, along that line, so there is actually a book, I believe the book title is Gut Feeling. That's by the German psychologist Gerd Gigerenzer. So Dr. Gigerenzer's theory is that if you represent the probability, um, so his thesis is that when you talk about percent, it's difficult for for human mind to understand because percents were invented. No, I shouldn't say invented. Percents were popularized after French Revolution for taxing purpose. So that was from evolutionary psychology point of view, that was a late concept. We are not used to that. But instead of saying percent, if you say if you say 8 out of 10 people instead of 80%, that's much easier to comprehend. So he developed some of what he called the heuristics, some of the rule of thumb. You can make a quick decision, kind of that's similar to the gut feeling, that's your intuition, if you represent information in what he called natural frequency format. The natural frequency, let me repeat, that's just instead of saying 80%, you say 8 out of 10. We have a mental image about the scenario.
And it's easier for people to conceive of or conceptualize
Right.
8 as opposed to 80.
That's right. As of 80%, because percent, that means 80 per 100. That's a difficult concept according to Dr. Gigerenzer's theory.
Yeah. Uh, we're moving into the last quarter hour, and I don't know if there's anybody out there who is would like to ask a question, but I usually also give my guests an opportunity to talk about what they're working on next. I mean, obviously, this paper's been very successful. Certainly gotten a lot of attention here at the college in particular. Uh, what are you working on now? Are you working on or next, should I say?
Okay, yeah. So before I talk about the next project, I want to also mention a little bit about my emphasis of using count. And the Dr. Gigerenzer, I have communicated with him. I actually asked him what I can learn from his psychological research to help LaGuardia students to better understand statistics. So one of the things, as I mentioned, we talk about count. And I also want to mention about the 170 people. That's the drug companies. They have to wait until they have enough people who got sick. Because if you only have 10 people and 8 out of 10 people who are in the placebo group, this is, the probability is not that low to have this kind of happening. You have to wait until, as I say, the FDA protocol is a certain number, and I calculate that's 170. So this also comes to the point that there were conspiracy theory that people say the late November vaccine availability was in somehow in connection with the presidential election. But you just have to look into the statistics to see that this is nonsense. You have to wait until enough people who got sick so that you can announce your results. So that's one of the point that students realize. Quantitative reasoning can be a powerful skill to refute conspiracy theory, to combat misinformation or disinformation. That's the point. So, so back to what Hugo asked me earlier. So, what am I doing now? So, I have been trying to um, trying to extend the work. When I wrote the paper that was in basically November 18th, Pfizer made the announcement. November 21st, I read the New York Times. That was 1 week before Thanksgiving. So I was able to use the Thanksgiving break to write the paper. At the time, that was based on New York Times information and the press release. Then, and after that, on December 10th, the Food and the Drug Administration, they had a meeting to discuss whether they should grant emergency use authorization to Pfizer. Then on November no, I'm sorry, it was December 17th. A week later, they did the same with Moderna. So the companies have to submit information and they have all the detailed statistics. So from those numbers, I was able to have a more comprehensive study of the numbers from the drug companies. And actually, just about 3 weeks ago, Russia, they had the Sputnik vaccine, and it's not sure about the vaccine because they didn't go through the 3 phases of trial. They just developed and they just start to vaccinate people. But eventually they publish their data. So I'm trying to and examining all the data and try to teach students how to analyze them to find a confidence interval and to communicate what's the meaning of the efficacy rate.
Yes, you use a lot of words, confidence interval and efficacy rate. Are these, the students who are taking this class, are they math, engineering, and computer science majors, or is this the general population of students?
No, this is just elementary statistics.
Right.
So since you mentioned about the keyword, I talk about the efficacy rate and we talk about confidence interval. So let me talk about confidence interval first. Before election, we have talked about a lot of polling numbers. We know candidate A is 55% versus candidate B and so on. So one thing I have been telling my students that is if you see a poll, they tell you 55% without telling you the margin of error. If they don't tell you plus minus 3 percentage points, for instance, don't trust that. That's nonsense. That's the confidence interval. They tell you the uncertainty of the poll. So when Pfizer tells you 95%, that's what I want to know. In addition to 95%, what plus minus what percentage points, and that's a little tedious math to go through, but that's just, as I say, just like having a poll number without margin of error. You don't trust that. And back to efficacy, we know that Pfizer claimed to have the efficacy rate of 95%. Back to what I have been saying, I think many times I'm getting repetitive. You have to ask yourself 95% of what? So using Dr. Gigerenzer's technique, we can imagine you have two communities. Both communities are identical, but one is vaccinated by Pfizer, the other is not. So if there are 100 people in the community they have not been vaccinated, there will only be 5 cases in the vaccinated community. So compare 100 cases and the 5 cases, you know that's a tremendous reduction of hospitalization rate and the resources. So this is the way we want to think in terms of numbers, in terms of natural frequencies.
Yeah, and I think what's great about this is that in a time where I think people are being pulled in a lot of different directions by the news agencies and things like that, to find some place where 1 + 1 = 2 makes people feel good. You know, it's like, actually, Frank, we're running out of time. Believe it or not, we've been doing this for about an hour, and I want to leave a little bit of time at the end for the music. I don't know how long Mr. Pope is going to play the music that we're taking out, but I wanted to give you an opportunity. Anything that you would like to say, or folks you'd like to thank, or anything before we go out, before we're done?
So I want to say thank to my colleagues. I have a lot of LaGuardia colleagues in my department, they help me to review. They review the paper and help give me feedbacks. So I want to thank them. And but the message for our student is to think for yourself and to look into the numbers.
Yeah, so there's a few questions I always ask mathematicians. I think one of them is the classic one is, so is mathematics discovered or is it an invention?
I think you probably need another show to interview other mathematicians.
Yeah. The other question I always ask is who stole my Einstein on the beach? I used to have a photograph of Einstein like in a lawn chair in his sandals at the beach, right outside my office, right next to where Rudy's office was, and
Right.
somebody walked away with it.
I
And
didn't do that.
so, well, I just want to thank you. And like I said before, if I can understand what you're talking about, then probably my audience can as well. And I think that I mean, I have my own belief, which is it takes about 5 years to learn how to teach a class. I don't know if it's going to take you 5 years to teach the lesson in a way. So you get more of those ahas, but it's just something, and by the way, once you learn how to teach it, of course, you have to start all over again and learn, because the population changes. Your jokes aren't funny.
Right.
Yeah, gotta
Exactly.
gotta start all over again.
Mhm.
But that's my experience. But I think you've helped me understand. And one of the things I enjoy your company whenever we do get to talk, is that I mean I find you to be a very learned man who can explain things to me in a way that I can understand them. And I think that's a gift. And you said you were repeating yourself. I just want to say, we know that repetition is one of the more important parts of education. So if you felt like you were repeating yourself, it's because you probably had to help me understand
Well,
very complicated ideas.
thank you for your invitation, and I enjoyed talking to you and exchange ideas and have the opportunity to share my 2 cents with the community.
Yeah, and maybe one day I will take your statistics class, and hopefully I can figure out what I'm doing. Uh, but anyhow, it's 1:55, and I'm going to give Mr. Pope a lot of room to play us out. So I just want to thank my guest today, who is Dr. Frank Wang from the Math, Engineering, and Computer Science Department, the Division of Academic Affairs. And he's been on today to talk about his paper, Using COVID-19 Vaccine Efficacy Data to Teach One Sample Hypothesis Testing. And hopefully the folks, if you were listening, you understood it better than I did. I might have to go back. I probably need to read it. Though I was saying before, the first 2/3 I was getting, but the minute, and I know Abdel had mentioned when he sent out the notice that you had used a special equation as part of it, and I couldn't remember which one that was. I was going to ask you about it, but if it comes to you, feel free to.
Yeah. So that's the central limit theorem. That's you have to have the sample size that's large enough to have a statistically significant result. And the way I explained to my student was that if you want to know a woman's opinion, if you only ask your wife, that's probably very biased. If you ask 10 women, that's a little bit improvement. But if you want to really understand the issue, you have to find a certain number of unbiased sample to do a systematic survey. So this is a reason I say that Pfizer and other drug companies, they have to have representative volunteers, and they have to wait until 170 cases to accumulate. It's not they want to wait until after the presidential election to release the results. At least that's the one way to explain the timeline.
And we should dedicate this show to those folks who volunteered to be tested because, they're saving lives. So again, Frank, thanks for being on my show, and thanks for folks for watching and listening. You've been watching what's going on here on LaGuardia Web Radio, WLGR, with your host, Hugo Fernandez, my guest Frank Wang. And Mr. Pope, can you please take us out? Thanks for watching and listening.